So I'm Liz Goldsmith with the Fiber Optics Technology Consortium, and I'm here today with Brian Davis from Corning. And we're going to talk a little bit about smart buildings and the technology to support them.
Hello, Liz. Thanks for having me. My name is Brian Davis. As Liz said, I'm with Corning. I am the Director of Market Development for in-building networks, focusing on what we need to do to think about how networks need to be fashioned going forward, not just based on what we thought about in the past several years, but really what's going to be the needs going forward in terms of smart buildings, re-entering buildings, and just what the network needs to look like in general. So thanks for having me. Looking forward to the discussion.
So Brian, can you tell me why you were recommending fiber deep architectures for smart buildings and enterprise applications, and what does that entail exactly?
Yeah, sure. It's a good question, and one that we in the industry we need to be considering much more so than what we have in the past. And so, in looking at the basic network architecture, it really goes back to thinking about how we're using networks, and a lot of things that we think about in terms of we are more dependent upon networks and networking technology within buildings than we ever have been before. Use cases are constantly evolving for what we're doing on the networks. And therefore, we're seeing new considerations, new devices, new connections that are being required on the network. And so one thing we can't do with all the new things that are happening on a network, what we can't do is apply the old, terminology, the old methodologies, I should say, to how we build those networks. And so when we think about that, it's not only a change to the network itself that we can do to better manage the building, but not only building management, but also better manage the health and safety of a building, better manage the comfort inside of a building. All of these things, I think that there's something about thinking about the architecture of the building itself. If we can take up less space with infrastructure, eliminating a lot of long horizontal cabling runs, reducing those instead of big bundles to single cables, and collapsing our infrastructure and our networks, converging it onto a single infrastructure, we save a lot of space. That has big implications, not only the cost of cabling and setting up the network, but also the cost of the building itself. So if we can reduce pathways and spaces, that's a pretty expensive part of the construction of a project. Now, if we take advantage of the distance and running fiber and power to the edge of the network, we can also think about not building as many IDFs or telecommunications closets or rooms, whatever term we want to use for that. And that enables us to really cut down on a lot of the front-end construction cost of a project. So if we take a reference of anywhere from $50,000 to $75,000 per IDF, it's a lot of construction cost. And then think about in day 2 and beyond that we can actually eliminate the amount of specific power and cooling that it takes in those rooms. And now we get an operational savings as well and doing the right thing for the environment. So it's really, thinking about it as holistically as not only the network itself, but also how it can affect the building as well.
Are you talking about a passive optical LAN architecture when you are referencing fiber deep architectures?
Yeah, that's another interesting question, Liz, because I think that when people hear fiber deep, the first reaction or the first thought is a passive optical network. And while a passive optical network can be very efficient inside of a building, we also realize that a lot of IT enterprise folks have already made their judgment on passive optical network. They're not interested in that technology. And so what we're positioning really is more so, and what I'm talking about is a point-to-point switched Ethernet, just done over fiber as opposed to being done over copper, and moving the electronics out to the edge of the network instead of, on each floor inside of a closet, putting them out on the edge where we break out into PoE ports to serve multiple devices. So we're still taking advantage of the ecosystem and existing base of PoE devices such as Wi-Fi access points, indoor cellular access points, sound masking, AV, and such. They're all PoE based, but feeding it out to the edge over a fiber network that is based on switched Ethernet. Now, inside this same network, you can implement PON over this network based on how you do it at the head end or at the main distribution frame. Again, really mainly talking about implementing a switched Ethernet. And that's really because a lot of the bandwidth concerns that we see at the edge of the network that continue to grow.
Okay, thank you. In terms of fiber type, should commercial buildings be looking at single mode fiber or multi-mode fiber when they're doing a new install?
Yeah, it really depends upon the network architecture that you select. So if you're going to go traditional with fiber up the vertical and then twisted pair copper across the horizontal, typically it's going to be about a 50-50 split between single mode versus multi-mode for that fiber up the horizontal. And it really depends on your selection of electronics and the gear you want to use in each of those IDFs. However, if you take advantage of the distance and reach that we see over single mode fiber, and you eliminate some of those IDFs, you're really looking at, again, using single mode to take advantage of, again, distance, as well as a virtually unlimited bandwidth pipe that you can put all the way out to the edge of the network. So there is room for both, but I think we're going to start seeing, just like we see in the data center market, you're going to start seeing more and more migration over to single mode because of its capabilities.
Now, what about existing buildings? How can you take an existing infrastructure and make it more fiber rich?
Yeah, I think inside of an existing building, probably the biggest hurdle you may have would be pathways, existing pathways, because once a building is built, the pathways are there, and it's really hard to expand upon that. And so being able to replace multiple category runs with a smaller cable, you can actually take advantage of maybe a pathway limited type of environment and be able to pull fiber out to the edge of the network without having to put additional strain. In fact, taking up less strain on pathways and spaces that may be limited since you're in an existing facility.
One of the traditional challenges with fiber networks has been powering the devices. How is the new fiber-rich architecture going to address that challenge?
Yeah, it's a great question, because when people think about fiber, you don't think about putting power over fiber, and we're actually not putting the power over the fiber itself. But so by use of a composite cable or composite construction of cable, where you have fiber and 12 gauge, 16 gauge, 20 gauge copper conductors inside that same cable, you can feed that power remotely or from a centralized location over DC power supply units. And then using a software-defined access node out the edge of the network that actually breaks that power and signal back out into a PoE port is really how you accomplish that. And again, when you think about the avoidance of having to put AC power to feed each one of these devices out the edge, and don't forget that we are seeing a growing number of devices at the edge, and you think about a concentration of those devices at the edge, it makes a lot of sense to do this over a fiber infrastructure that we can combine that capability of doing both virtually unlimited bandwidth as well as DC power out to the edge of the network.
What are some of the hurdles that you come across in terms of changing the traditional mindset about infrastructures for smart buildings?
Yeah, sure. It's a good question, Liz. I think that as we've talked about an off fiber infrastructure or an all optical architecture, whatever terms that we want to use there, it's definitely a vast departure from the way we've been designing networks over the past. And so in order to think about that, we really have to challenge the mindsets and kind of end that copy paste mentality to designing network technology for a building. So one of the things that has to happen first is the choices around network technology have to become much sooner in the cycle, in the design cycle. It can't be, all right, all that stuff happens later. We don't need to worry about that in the architecture of the building. It's got to happen much, much sooner. And that, again, requires the adoption of a different mindset. We can't take advantage of reduced pathways. We can't take advantage of some of those energy savings that we get out of not having specific power and cooling inside of IDFs if we don't eliminate the IDFs. We can't take advantage of a lot of these cost savings if we don't change the mindset. And that's why we're really quick to point out that while there are advantages with the network itself, there are advantages in the building as well. And we kind of think about it in terms of, less can be more. So the idea to drive a network architecture that requires less materials but delivers more performance, designed for a building that can deliver, more of the desired technology while requiring less energy and resources. And it seems like we would jump all over that. But again, that change in mindset, and actually the change in that, again, that copy paste type of how we've been doing buildings for a long time is something that's really challenging, and that's probably the biggest hurdle that we're trying to cross and driving the industry forward.
Thank you, Brian.
Thank you.